deviation. All of them come together now to give us what the deviation, the angle of deviation. Pay attention because I want us to understand before we use the formula in question. Now this will be I1, R1, and this other one which is represented, which will also be R2 and what I2. So according to the law, the rules of this deviation, we're able to find out that D is equal to I1 minus R1 plus I2 minus R2. That will give us deviation. Since the angle is not given to us, note the angle of deviation is not given to us here. So what are we going to do now? Our first I, incident ray, there will have it to be. Welcome to Study Guide for today. We'll be looking at refraction of light. So what is refraction of light? Refraction is the change in direction of light. The change in direction of light. That is to say, when a light passes through a media, one media to another, that is denser, from denser to less dense medium, or from dense to lesser dense medium, as whichever way, whether it's coming from the denser one to less dense or from less dense to denser medium, there will be a change in direction of light. And that change in direction of light is what we call what? Refraction. Now in refraction, for example, let me just make a sketch of what we mean. For example, we have two media here. This is the two media, and this is medium 1 and this is medium 2. So as the light is getting through, the ray of light, change direction of ray of light, like we said before, the light gets to the normal point. The normal, this is the normal, this is the point. The normal is the ray of light, and this one is what we call the incidence. The incidence angle of incidence is here. We can also use I to represent it. So this is the incident ray. As it is the incident at this point, there will be a change of direction. This change of direction, this is where we call the angle of refraction, which we normally represent by with R. So as it gets to this point, there's always a change in direction. So now, because in the law, we have about two laws of refraction of light. The first law says that the incident angle of incidence, the normal, and the angle of refraction. No, not that. The incident ray, the normal, and refracted ray, all of them lie in the same plane. The second law says that the ratio of angle of incidence to the ratio of refracted angle of refraction is a constant. That constant is what we call refractive index of the second medium, that is this one, medium 2. This is refractive index of the medium 2. That is what it is. So in this case, we have some method. That is, if you want to find the refractive index of any medium, let's say we're looking for the refractive index of a glass, then we can use, based on what we have seen so far, we can say N, refractive index is normally represented by N, that is sine I over what? Sine R. This will give us the refractive index. Refractive index also can be calculated using the speed of light. In that case, we say velocity velocity of light in air over velocity of light in glass. This also will give us the refractive index. Another one we normally use is real depth over apparent depth. Now the apparent depth is the depth that appear. For example, when you put something, so if you put something like a stick in the water, you notice that it will be as if that the stick is bent somehow. This is because of refraction. And maybe if you go to the something like a pool, a swimming pool, you notice that when you stand there, it will be as if the the pool is not very deep enough. This is because of refraction altogether. That results to what we call the apparent depth. That's what gives us the apparent depth. Real depth is the actual depth of the, let's say, of the pool. Why this apparent depth has to do with the as a result of refraction of light. So with this thing we have here now, we're going to be looking at some calculations where we'll be applying them, how we're going to be applying them in our calculations. So the first question we'll be looking at here. Okay. So what we have here now is the questions. And meanwhile, I want to let you know that these questions will be also in the description of this very video, so that you can always look at it. So here we have the questions. It said that a ray of a ray of light in incidence at its incidence, that should be its incidence only, is incident at an angle of 30 degrees on a glass prism of refractive index 1.5. Calculate the angle through which the ray is minimally deviated in the prism. That's the first one. Let's start with this first one first. So here we are looking for angle of minimal deviation in the prism. So what do we have here? We have some basic information that we can use to really get what we are looking for. The first thing we have here is an incident angle. We have incident angle, which we normally use I to represent, which is 30 degree. We also have, what do we have again? Refractive index, which is 1.5, but refracted ray, okay, refracted angle, we don't have it, it's unknown. It's unknown. Another thing we don't know here again is the what? A D, which is deviation, minimal deviation, which is also we don't know. We don't know this thing. But then, to look at it very, we find out we can, if we're able to get this, we can get the other one. So in this case, we are looking for minimal deviation. So by using the equation, we know that n is equal to, that is refractive index equals to sine I over what? Sine r. That one is established already. So what it simply means here is that, so for us to get this thing done, we get the sine. We know that sine refractive index is given to us, which is 1.5. Sine I is also there, which is 30, and then we can also get this very angle, then the sine that we're looking for. So in that case, what are we going to do here? We can cross multiply. If we cross multiply, we have 1.5 sine r equal to sine 30 degree. So now sine Sine r will then be sine 30 degree over 1.5. Sine 30 degree will be something like, I think it's 0.5. Then we have 1.5 here. We have 1.5 here. So when we divide this, we will get, what we have is 0.333. Getting the arc of this angle, the angle itself, I think it should be either 19.447 approximately. So let me just get my calculator. So that will give us, let's look at that. It's already confirming whether it's actually what it's supposed to be. Okay, it's correct. 19.47. That's okay. So let's continue. Now we have the angle itself, the angle refracted angle. We can go ahead in solving our problem now. Now this is the meat of the whole matter, the real deal of the matter now. Note in this very question, we were not given the angle of the prism. The angle of the prism is not given to us, but we know that. Yeah, let's say, assuming it's a triangular prism, because it's not stated there. Assuming it's a triangular prism or any other prism, because the formula we're going to be using is applicable in all prisms. So assuming this is our normal, and the angle of incidence pass through here, then it will do what? Refract. After refraction, it will bounce back here, then come out of this place. You bounce back and come out of this place, they're coming out of here. Yes. So here we have sine, another, that is incident ray, refracted ray, incident ray from this side. If we're coming from this other end, it's incidenting here. Then here is also our was refracted ray. So based on that, we can say that all of them will come in here together to give us a deviation. All of them come together now to give us what? The deviation, the angle of deviation. Pay attention, because I want us to understand before we use the formula in question. So now this will be I1, R1, and this other one which is reflected, which will also be R2, and what? I2. So according to the law, the rules of this deviation, we're able to find out that D is equal to I1 minus R1 plus I2 minus R2. That will give us deviation. Since the angle is not given to us, we know the angle of deviation is not given to us here. So what are we going to do now? Our first I, incident ray, there will have it to be, remember the incident ray here and incident ray there, they are all the same, they are equal. Refracted ray here and refracted ray there, R1 and R2, they are equal. So what we're going to do here is that since this one is 30 minus what? 19.47, all in bracket, plus 30 minus 19.47, all in bracket. So if we have to do this, we subtract. On subtraction, what we get here will be 10 point plus 10.353. Adding up together, we will have the refracted angle of minimal refraction. There will be deviation will be 121.6 degree or 21.1 degree approximately. So this is the answer to the first question. So now we're going to be going to the next one, which says the velocity of light is the velocity of light in air and in glass are 3 times 10 raised to the power 8 meter per second and 1.8 times 10 raised to the power 8 meter per second respectively. Calculate sine of angle of incidence that will produce an angle of refraction of 30 degrees for a ray of light incident on glass. So this is what we're going to be doing. So in this case, find out that some of the things that are given to us, the velocity in air, which is what 3.3 times meter per second, and then velocity in glass also given which one? Yes, in glass is 1.8 times 10 raised to the power minus meter per second. The next one is angle of incidence, angle of refraction, which is R. It's also 30 degrees. Now we're looking for the sine. The question says sine of angle. That means talking about the incidence unknown. Unknown. We don't know this one. So the next thing we're doing here to get this in accurately, find out that based on what we have already established in this, find out that you can also use this to get our refractive index. Now remember that refractive index is equal to velocity of light in air over velocity of light in glass. So with that now, we substitute that of air is, and that of glass is 1.8 times 10 raised to the power 8. So then this can go. The next thing we have there is 1 divided by 1.3 divided by 1.8. We'll have this cancel out, we have 1.67. So this is our refractive index. So now we have the refractive index. The next thing we are going to do is to what? Substitute. Since we're looking for the angle, now we can use this formula now, which is I over what sine R. So this next thing we are going to be using to get this thing done. Our R already is given to us, which is 30. Now what we do, our refractive index is this 1.67 equal to incident angle sine I is not given to us, so we can now we have a sine R is what 30. Note, we are trying to find out, the question says we should find out this sine of angle. So by doing so, what we have here will be, if you cross multiply this, we find out that sine I will be equal to 1.67 times sine 30 degrees, and sine 30 degrees should be something like 1.67 times 0.5. That should be sine 30 degrees. So by doing this times 0.5, we have sine I will then be 0.8333. Now, this is the actual question they asked us to find. They say we should find out the what? They say we should find out calculate the sine of angle. So the real angle, now this is the thing, the real angle will mean that we're going to find out if we want to find the real angle in this case, it will then be the actual angle here. That is the sine itself will be approximately. So the next question we'll be looking at now will show us how we can apply the other other rule formula of calculating the refractive index. But before we go into that, if you're joining us for the first time, I want to encourage you to subscribe. Now, if you want to communicate with us, you can also leave your question in the comment section. Now, remember to subscribe, share, and like. If you're joining for the first time, please don't miss subscribing. Thank you so much. Let's go over to the next question. We're going to be looking at the next. So let's look at the last question here. So that a transparent rectangular block 10 cm is placed on a black dot. The dot, when viewed from above, is seen 6 cm from the top of the block. Calculate the refractive index. Now, based on this question we have here, to calculate the refractive index, we need this formula, that is real depth over what? Apparent what? Depth. So from here now, I believe that after solving this, you'll be able to know how to handle all these formulas, and you can see even how easy they are. But then don't always be. Whenever you see a question like that, feel free to try your hands on them so that you get used to each of them. So we have our real depth. The real depth is what? Our real depth is now real depth. Real depth is what? 10 cm. While apparent depth is equal to 6 cm. So using this formula, we have n will be 10 over what? 6. So 10 over 6, that will give us, sure, okay, that will give us 1.67. That's our refractive index. Thank you so much for coming so far, and we're happy that you enjoy the class to this point. I want to hear from you. You can leave anything you want to tell us in the comment section. We'll always attend to you, and make sure you subscribe if you have not, and then make sure you share. That's a very important, one of the important things you can do for us.